equation x in exponent x is equal with x in exponent 5. So before I go any further, let me make some restriction. Let x is element of integer. And let me write this equation. X in exponent x is equal with x in exponent 5. Just by inspecting this equation, we already see x is equal with 1 and minus 1, because 1 in 1 is equal with 1 in 5, and minus 1 is equal with minus 1 in exponent 5. So we already see by inspection. But if we want to justify our results, this x is equal with 1 and minus 1, and to find the other solution if there exists another solution, first of all, let me go here and let me apply multiplication property of equality, which now I'm going to multiply both sides by x squared. If I multiply both sides by x squared, the equation is going to take this form. X squared times x in x is equal to the x squared times x in 5. And now I'm going to apply here addition property of equality. I'm going both sides to add the minus x in exponent x. If I'm adding both sides, so this equation is going to take the following form. X squared x in x minus x in x is equal to the x squared x in 5 minus x in x. And now both sides I'm going to subtract by x squared x in 5 minus x in x, because one side I want to make equal to 0. And if I'm taking a little bit of shortcut, so then we have x squared x in x minus x in x is a minus x squared x in 5. In 5 is a minus x in x. So this is going to change the sign. It's going to be equal to 0. But now, before I go any further, this x in x, I am going to substitute by x in 5. Why? Because we already see x in x is equal with x in 5, according to this first condition, to this given equation. So instead, when I have x in x, I'm going to substitute by x in 5. So let me rewrite this equation here again. And let's see how it looks. So we have x squared x in x minus x in x minus x squared x in 5 is plus x in 5 is equal to 0. So instead of x in x, what I have here, this equation, I am going to substitute by x in 5. And now I'm looking here, can I factorize this one? If I'm looking here in the first group, I have the common factor is x in x. So we can write x in x times x squared minus 1. And in second group here, if we are looking second group, I have x in 5 is a common factor for both of them. And I can write minus x in 5 is x in squared minus 1 is equal with 0. And if we are looking here with this, what is the common factor for these two terms? The common factor is x squared minus 1. So I can write x squared minus 1. And what remains is x in x minus x in 5. X in x minus x in 5. Everything is equal to 0. And now, if I'm taking this factor, this I can factor it further. This we can factor x minus 1, x plus 1, and x in x minus x in 5 is equal with 0. So that's what we can write. And according to zero factor theorem, we can write x minus 1 is equal with 0. I'm taking shortcut, and here is the x is equal with 1 is one solution. So this is very easy. And if we are if we are taking x plus 1 equated with 0, and we solving for x, x is going to be equal with a minus 1. That's what we have here. And if we are taking the third factor here, x in x, if we are taking x in x minus x in 5, and we equate with 0, this one can be x in x is equal with x in 5. According to the exponents property, if the base is the same, exponents are the same, so x is equal with 5. And those are the three solutions. X is equal with 1, x is equal with minus 1, and x is equal with 5. And all of them are elements of the integers.